Hi, welcome everybody. Thanks for joining us to discuss automation strategies to protect sensitive data. We'll also be going through a case study about these topics that we're going to talk at the beginning of the deck. I'm Steve Tao. I'll talk a little bit about myself in the next slide. Joining me is Greg Galloway from Artist Consulting. I'll let him introduce himself when he starts talking, but he's kind enough to talk about a case study with a real live customer where he went through these challenges that we're going to talk about today and how they solved them. So I'm the CTO at Immuta. Our goal is to enable the legal and ethical use of data. We were just recently nominated as one of Fast Company's most innovative companies of the 2020 year, which is pretty exciting. As you can see here, we're also a very strong partner with Databricks and AWS. The reason I bring this slide up is that I've had conversations with hundreds of customers, and what we're trying to do in this deck today is boil down the common themes that we see the customers struggle with, and then bring that to reality when Greg talks about his case study. And here's a quick look at the agenda. So I'm going to cover all these topics, starting with why you should care. So if you think about Databricks, it is a unified data analytics approach. You can really think of it as these three pillars of data, AI, and people. So you, of course, need the data, and then you, of course, need the tools to do the machine learning and analytics against that data. And it allows you to have one place where all that can occur, have your data brought together, your people on that data, building the algorithms they need to achieve whatever they want to achieve with their data. However, if you lay governance on top of this, a lot of people kind of throw up their arms and roll their eyes and say, oh, great, this is really going to slow down everything I'm trying to do. With Databricks, for example, you really need consistent controls no matter what language the user wants to use, like Python, SQL, R, or Scala. You really want to have 100% of your data live there. And a lot of people hold back bringing their data into Databricks because they're concerned about the privacy and sensitivity of that data, which is a challenge. And then, of course, you need to involve legal and compliance as part of the people that are involved with this entire framework so they can help make decisions and understand what's happening in terms of policy. So I'm actually here to argue that this shouldn't slow you down. And in fact, it can make you more efficient and get you more access to more data across all of your analytics and meet your goals. So how is that possible? So the first thing we're going to cover from that angle is some different architectures that exist in Databricks to manage this sensitive data. So before I dive into those, this is a quick overview of a simplified snapshot, if you will, of how you do access control. So there's, of course, table level controls. So this would be, you can think of these as entitlements, who has access to the entire table. And then within that, you get more granular, such as column controls, who can see the columns. And I'm going to talk a little bit about masking of columns and what that means. Then you can do things like make rows disappear, or that's termed row level security, where some people can see some rows, but other people can't. And then you can even go deeper than that and do cell controls, which is similar to column controls, except not all the cells in the column get masked, only certain cells based on potentially other values in that same row. So here's some different options for you in a Databricks world. And in fact, this spans beyond Databricks. And I'll talk about each of these in the subsequent slides. But you've got control at compute, control at storage, and then probably something that people aren't familiar with, which is the policy is actually separated from the platform altogether. So the first one here is controlling at the compute layer. And I think everyone's very familiar with this. This is pretty much how every database works, where you build the rules in the platform on who can see what. And Databricks has something called table ACLs to manage this for you, where you can define what roles or users have access to what tables. This is all defined within the Databricks construct. And table ACLs is only going to get you the table level access controls. This does not enable you to do column, row, or cell level controls. So an example supported policy here at the bottom of the slide is only allow members of data engineering group access to the customers table. So moving on to the next one, we've got control at the storage layer. So this is fairly unique to the cloud, or I should say very unique to the cloud, in the sense that instead of doing the controls natively in Databricks, Databricks can actually do something called credential pass-through and pass that down to the cloud provider at the storage layer and let them make decisions on who should see what buckets or folders or files. So you can keep using your regular old controls that you have in ADLS or S3, which define what roles have access to what files in storage. And that basically propagates through to the tables that you're using in Databricks. So again, this is really just table level controls, because at the end of the day, it's files that back the tables that you're restricting access to, and you can't do things like column, row, and cell. So this example policy is very similar to the prior one I just described, except instead of allowing the engineering group access to the customer table, we're saying the customer S3 directory. So what folks end up doing, so in those first two scenarios, as I mentioned, they don't do column, row, or cell. Kind of a naive approach to solving this problem is, let's just create a bunch of views or copies of the data to manage these different access levels or the granularity that I need. So I'm calling them lenses in this slide, so different lenses into your data. And so we've got that first lens. So you have the original table, which everyone can see everything in that original table. And then you could potentially build a copy that removes that one column in purple in that lens number one. You could have another lens which removes that same column, but also removes some rows. And you could have a third copy or a third view that removes a different column, but has different rows. And then you have to manage access to all these copies and views separately. So this quickly, as you can see, can explode out of control. And so what we actually call this is an anti-pattern. So an anti-pattern meaning it sounds good on the surface, but it actually makes more headaches for you down the road. So one of the obvious issues here is that in a lot of systems, the user querying the view needs access to the backing table too. So that really defeats the purpose. So you really have to end up creating copies, which is the case with Databricks. And so if you're creating all these copies, you obviously create this proliferation of copies all over the place. And in order to maintain all those copies, you need a series of ELT jobs to create all those transformations and create all those data copies and views. I call this ELT spaghetti. But even adding more complexity to that is if you have updates happening, historical updates, like if 3 months ago, someone now updates a value in the table, you need to account for all those historical updates and when you're creating your copy so that everything stays up to date. This could get really, really complex. And then, of course, as I mentioned in the prior slide, as you're creating all these new copies or views of the data, that means that you have to manage all the roles that have access to those copies and views. So this leads to role explosion. So all of this is going to cost you a lot of time and money, which is why it's an anti-pattern. And just, a very simplistic example down here at the bottom is you have 100 tables and you need 3 different lenses into each of those tables. This is probably, it's not realistic that it would always be 3, but just bear with me for this example. That would mean that you would have to have 300 ELT jobs, which create 300 different copies and views, not counting your original table. And then you're going to need somewhere between 3 and 300 roles, depending on how homogeneous those 3 different lenses are across all those tables. So this can quickly get crazy with very few lenses on, I would argue 100 tables is very few tables. So what do you do? So this is where really the separate policy from platform comes into play. So just like the big data era required you to separate compute from storage to scale, the personal data era, my argument is, requires the separation of policy from platform. And so you can define your policy external of Databricks and storage in a consistent way to manage these controls. And in fact, if you do this, you get beyond just table level controls, and it can be enforced dynamically. So you're not having to create these copies or views. One user querying the same table as me may see a completely different view or lens into that table than I would based on the policy. And this can happen down to the column, row, and cell level. So an example kind of crazier policy that you could support is, by default, everyone can see rows greater than 90 days old, but people that are insiders can see data newer than 90 days, but they can only see it for their region. And we'll come back to this example in a little bit. Okay, so why? So I'll elaborate a little bit. Why would you want to separate your policy from your platform? So it's the same reason that I guess that most of the people watching this separate your identity management from your tools, because you want consistent users across all those apps. You don't want Steve to be called Steve in one app and Steven in another. You want consistent authentication across those apps, and the way people authenticate to be consistent. You want complete visibility into who your users are and what their groups and attributes are. You want consistent audit on when people are logging in to where. And I think probably the most important thing is, the reason why a lot of us use Okta is it's Okta's day job to build identity management. They're going to give you all the necessary bells and whistles that you need to do what you need to do. Similarly, you would want to separate your policy management for very similar reasons. You want consistency in the policy enforcement across your databases, compute, and storage. You want complete visibility into the policies that are being enforced. You need consistent audit across all your data interactions, so your queries, but also the management of your policies, who's changing what in your policy rules. And similarly, it's their day job. So us at Immuta, we are a policy management platform that exists separate from the platform. And this is why we're able to do a lot of the very advanced anonymization techniques I'm about to talk about, but also the dynamic enforcement down to the cell, row, and column level. So if we lay this back on our slide that we started this with, when I said, hey, don't let governance slow you down. Well, if you're using the right tool for the right problem, it doesn't have to slow you down. So you can have consistent controls across Python, SQL, R, and Scala, which Immuta supports. And in fact, you can see I have a bunch of other icons in this triangle now. It doesn't have to just be Databricks. You can have consistency no matter where your data lives. And then down here on the left, you were afraid to move your data into the platform because you didn't have the controls you needed. Well, now you can move it all there and enable your analysts to have more access through anonymization techniques, which I'll talk about, where you can actually gain utility from data that typically would have just been completely hidden. But now we can kind of fuzz it or half hide it so that you still gain some utility, but also are maintaining some level of privacy. And then also, of course, now your legal and compliance teams can see everything that's going on, understand what policies are being enforced. It's not a black box per compute that you're using. So we actually are accelerating your data initiatives through governance. Okay, so now that we understand the architectures and some concepts around how to do the fine-grained controls, I'm going to talk a little bit more about anonymization. Okay, so when we talk about column controls, it really shouldn't just be about should you see this column or not. This can't just be a binary decision, and I'm going to make an argument why here. So a slight tangent. So I know stuff about Judd and Leslie Apatow. So they're having a great time in their taxi cab in New York City here. And the New York Taxi and Limousine Commission, this happened a while ago. I think this data has been around for like 8 years now. They released all their information about the taxi pickup and drop off times and locations, the amount of the ride, the tip amount. All this data seems fairly harmless, right? Well, Judd and Leslie may not think it's harmless. So if you look closely at this data, you'll see there on the bottom left that we've got the taxi medallion and pickup time. And then over on the right, we also have the tip amount here. And if you look up at that image, you can see that we also have the taxi medallion. So what some tabloids did, I think it was Gawker, where they were able to map the taxi picture based on the medallion and the timestamp of the picture with the taxi data. And amongst millions and millions of records, they were able to find Judd and Leslie's ride. And because of that, they know how much Judd and Leslie tipped the taxi driver. There are a bunch of other celebrities they did this to who tipped the taxi driver $0, which I'm not going to disparage here, but at least this gives you a sense of what happened with this kind of attack. So this is an example of what's called a linkage attack. So we took some information we know from the outside world, in this case, the medallion and photo time, and we were able to link that to the medallion and pickup time in the New York taxi data to break privacy. So New York actually kind of thought ahead a little bit and said, hey, let's mask the taxi medallion. This might have happened after this attack. I can't remember. But it wouldn't have mattered either way. And I'm going to tell you why. Even if you mask that direct identifier of the taxi medallion, you could still do this attack. So if you look at Judd and Leslie here, so remember, we have the medallion and pickup time attack. So if we go ahead and hide the medallion, now that attack doesn't work anymore. But we can simply use the pickup time and location if we knew that to break privacy, because then that's unique enough to uniquely identify them amongst those millions of rows. So let's go ahead and hide the pickup time. Well, what if I knew the pickup location and drop-off location? Again, well, let's hide the pickup location. So you can't do that. All right, well, what if I know the drop-off location and drop-off time? Well, crap. Okay, let's hide the drop-off location. And so I think you get the idea here is that as you keep hiding what are called quasi-identifiers or indirect identifiers, you just make your data useless. You're going to end up hiding everything. So how do we solve this problem? So, and this problem exists well beyond just my silly taxi example. So I'm going to play lawyer for a moment. And this is language from the CCPA, and there's also similar language in the GDPR. So this first orange blob is basically discussing, if you anonymize or de-identify your data well enough, CCPA doesn't apply. Cool. This is the get out of jail free card. I can analyze my data all I want because I've anonymized it well enough. But as we all know, nothing in life is free. And so PII is defined as information that identifies, and this is in the CCPA, that identifies, relates to, describes, or is capable of being associated with, or could reasonably be linked. So they are talking about a linkage attack, like we just talked about in the taxi use case. So if you want to anonymize your data, you need to worry about quasi-identifiers and indirect identifiers. So these little bubbles kind of walk through the kinds of identifiers you would want to be concerned with and align them to the taxi data and talk about some techniques you could use to mitigate them. So we've got the direct identifiers, which are the taxi medallion. We have the indirect identifiers, which is the pickup, drop-off times and locations. And that was what was used for the linkage attack. And then we have sensitive data like the tip amount, which is what was released about the celebrities that was embarrassing, right? And so let me go to the next slide, which actually discusses some of these privacy enhancing technologies. So there's a bunch of different ways you could do this through obfuscation, generalization, and randomization. And these aren't techniques that Immuta made up. These are called privacy enhancing technologies that have been around for a while. But actually implementing them and enforcing them in something like a Databricks and Spark dynamically is highly complex and is not something you can just kind of on a whim ask your data engineering team to do. So these are things like differential privacy, randomized response, which can replace the tip amount with random tip amounts, k-anonymization, which can remove highly unique values, rounding, which aligns with generalization of making the pickup and drop-off locations and times less specific. So lots of tricks you can do to balance utility and privacy. So to show you what I mean by that balancing, let's apply some of these rules to the taxi data. So of course, we're going to mask the direct identifier, which is the taxi medallion. But then we've got all those indirect identifiers, the drop-offs and pickup locations and times. So rather than just completely blocking them, we can generalize them to make them less specific. So we remove the minutes and seconds from the times. We remove some precision from the coordinates in the drop-off and pickups. So an analyst, this shouldn't really matter, right? They could still do all their aggregate traffic analysis that they need to do from this taxi data, but now they cannot do that linkage attack that we showed earlier. And similarly, we could randomly replace the tip amounts if it made sense, where sometimes we could replace the tip amount with a legitimate but fake tip amount. So the attacker doesn't know for sure what the tip amount is in the data. But again, so rather, basically, if we just naively blocked all these columns, all we'd be left with is the total trip length, or the trip cost. But with these anonymization techniques, you get full utility out of this data while also protecting privacy. Okay, the last thing I'm going to talk about before I turn it over to Greg is scalability. So when you start thinking about all these lenses into your data and all these anonymization techniques you need to consider, this completely explodes the universe of, if we go back to our example of views and copies, you would have to create and manage, and also the roles that you would have to manage. So you could see a world where there's 5 different geographies where all your data lives, with different controls and different business units with different rules and different regulatory controls you need to think about. This is beyond human comprehension and beyond a human be able to do this manually. So how do you manage it? So the first thing you can do is this technique called ABAC, which is how Immuta happens to work, where you can define your users in an ABAC world, which is attribute-based access control. You define your users, like Steve is 6'2", brown hair, works for Immuta, however you want to define your users, and then you build rules separately from that definition that make decisions on the fly. Oh, Steve is querying and he's part of Immuta, he's not supposed to see this table, I'm going to block him. RBAC, on the other hand, conflates who the user is with a role and what that role should have access to. So now basically you have to create a role for every different access decision you need to make, which quickly explodes out of control. So if we go back to this example where we want everyone to see data older than 90 days, but only insiders can see data younger than 90 days, but they can only see that younger data for their region. So I went ahead and built a policy and a tool called Apache Ranger, which is our RBAC-based policy manager. And in this case, we have to build a rule for every possible combination of region in insiders. So we could have an insider in the East region, so we need a where clause for that. We have a insider in the West region, we need a where clause for that. We might have some insiders, and I didn't build this in the rule, that are both in East and North. And in that case, we'd have to build a separate rule for that. Because remember, we're conflating who the user is with the policy that they should get. So if we were to count for every single combination, this would be 19 different roles we would need. And this is only for 4 regions. So the problem is you have to predetermine all these roles up front and build the policy against this. And access is implied. So I don't know what giving someone Insider East really means, because it's all conflated with the policy. So it's very hard to comprehend on where you should add your users role-wise and what that actually means, because it's all implied. Whereas with ABAC, you simply define your user. So Steve is an insider in the East, and this is actually a visualization of building the rule in Immuta. This is the actual tool. But we assign the attributes to the user, and then when I query the data from region East, it's going to dynamically see that I'm coming from the East region and apply that policy on the fly. So I just have to build the rule once, and it will also be future proof. So if I add a new region Central and I query the data, it's actually going to see Central and apply the rule appropriately. Whereas with RBAC, I would have to remember to create a new rule for that Central role. So there's a lot of power in ABAC. Okay, the last thing is physical versus logical. So just like ABAC gave you scalability, this gives you scalability as well. So if you are building a rule against a physical table, like I could build the rule for credit card transactions, I want to mask the customer last name and credit card number columns. So I'm calling out the actual physical table. But this could be really painful if you have thousands of tables and all those columns are named differently, right? This would be a nightmare job to have to build these policies one at a time. So if you build them at the logical layer instead, you can actually tag your data with person names and credit card numbers. So you're abstracting the actual physical table and databases. So some of these tables could be in Databricks, some of these tables could be in Oracle, wherever your data lives. We don't care what the column names are, what the table names are. that logical layer abstracts all that, and you can build policy against that logical layer. And Immuta can actually go out and discover all the different places where this sensitive data lives through our machine learning driven classification algorithms to find where are person names, where are credit card numbers, and auto tag that for you. So you can build your policies this way in a scalable manner. Okay, so that's it from me. I'm going to pass it over to Greg to actually talk about how he ran into these problems in the real world and applied these techniques to solve it.
Thanks, Steve. Well, I hope this case study will help bring the message home and make it a little more concrete. I'm Greg Galloway with Artist Consulting, and I'm an Azure architect and a principal. We were able to do a case study, a proof of concept with a particularly large Fortune 500 company that I think applies here. So this company made a really large bet on Azure and on Delta Lake, and particularly on Azure Databricks as really the only way to get data out of the data lake and make sense of it. And so they came to us with some security requirements. They were both internal policies in addition to industry regulations, such as the CCPA and others. And so Artist Consulting was brought in to perform a proof of concept and test out how to accomplish these requirements, both in Databricks and in Immuta. So diving into the high-level architecture for this proof of concept, they had an Azure Data Lake store that was central. And on the left, there was a data engineering focused workspace that had read-write access to the data lake. In the middle of the screen is a workspace for Databricks that was really focused more on end users, both BI and data science end users. And that workspace and the clusters within it was integrated with Immuta. And so there were a couple of different ways that we tested allowing users to get data out of Databricks in a secure manner. And Immuta was able to seamlessly secure any of those methods. The one on the bottom is through Databricks notebooks. A user can access tables in the Immuta database within Databricks. They could also use Spark drivers in tools like Power BI. Or alternately, they could go through the Immuta Postgres interface. Immuta pretends to be a Postgres database to make some of the data available if that's a preferred approach. We recommended generally users using notebooks or using Spark drivers to connect. So if we summarize the results of the proof of concept, there were a number of requirements or use cases, and those are listed on the rows, 7 key ones. Then we did tests to show essentially what could be accomplished with plain vanilla Databricks without Immuta. And then we repeated those particular tests with Immuta integrated in order to determine what's the best security pattern, how do we meet these requirements, how do we make this successful in their organization. So you can see at a quick glance that we were able to do 5 or so to some degree with plain vanilla Databricks. But with Immuta involved, we were able to really well accomplish all of the requirements. So I'll go through each of those. So first of all, the first one was redaction of older data, and this was easily accomplished with Databricks. Essentially, we were able to create a new copy of the table so that we're wiping out the Delta table history and the time travel. And we were able to do that with Databricks by creating a second copy of the table and doing some renames. The next requirement was around masking, and this was, of course, a key requirement. For example, social security numbers and credit card numbers and such should not be visible except under very specific situations. Maybe the HR department needs to do a study for a couple of days, so they need time-limited access to data unmasked, but everyone else should only be able to see data masked. In Databricks, you were able to do some approximation of this, maybe with the MD5 hash function and views, but it wasn't a great solution. Immuta was by far the best solution here. It offered a number of different ways to format the mask, and it also allowed you to do very convenient things with global policies where you didn't end up with a bunch of spaghetti views and spaghetti code like Steve had talked about. The next requirement was around deleting the detailed data, but keeping aggregate data. And that was easily accomplished with Databricks. The next requirement was around row-level security, and this was a key requirement for them. They were very insistent that there was a large, complex set of requirements. Each user should only see their region, for example, but there were a number of other requirements. And like Steve had talked about, there is a naive approach where you sort of an anti-pattern, like Steve talked about, where you end up with a ton of views in Databricks. And that really wasn't going to meet the needs of having this dynamic based upon user attributes and user roles. And so with Immuta, the solution was very easy. Global policies made it easy to apply a solution to all tables that had columns tagged in a certain way, or had data of a certain type. And the policies could be based upon user attributes. So that made it very straightforward to set up with Immuta. The next requirement was around auditability, being able to see who has access to what and also see who accessed what. And so with Databricks, there's some integration with Azure Diagnostic Logs and with some metadata queries to see who has access to particular tables. But I would say definitely that Immuta is built to do this. It had a very user-friendly UI that would give you deep insight into exactly what people are doing and exactly what people have access to. So that was a superior solution. The next requirement was around manageability. So easily Immuta is built for this. It's a single pane of glass that lets you manage policies instead of thousands of views that you have to maintain and test and hope you don't make a mistake. And then the last performance, or the last key requirement, was around performance. So particularly related to row-level security, we did some pretty intensive testing to make sure that applying policies wouldn't degrade security. And the main recommendation we would have is to make sure that you use policies that are based upon user attributes. And particularly for their organization, they're using a feature called the external user info endpoint that would let them populate those policies. And that seemed to be the best performing way of the ones that we tried in Immuta. And overall, they were pleased with the performance. I think one of the key reasons is that Immuta integrates so deeply with Spark that it's able to push its policies down into Spark and have it be calculated in scalable compute. So overall, the customer was happy. It was a very successful POC. Just on a personal note, working with Immuta was one of the best product support experiences I've ever had. They were willing to jump in and help and offer suggestions. And I don't think that the proof of concept would have been successful without Immuta, as it brings a lot to the table.
Thanks, Greg. That was a great overview, and I think you really brought home my points in a concrete way. So let's summarize everything that we talked about today. So go on to the next one. So again, just going through the points we touched on is choosing the right policy architecture. So in the example Greg walked through, of course, they need a lot more than table level controls. So hence they decided on this architecture where we separate the policy from the platform. In his case, using Immuta, and successfully avoided that anti-pattern of creating hundreds or thousands of views and trying to manage that. And then, of course, the second big point is column level controls needs to be a lot more than a binary you have access or not. You really, if you want to leverage your data effectively, especially in this world of regulatory controls around privacy, and it's not going to stop. You're going to really need to consider how you manage these privacy enhancing technologies on your indirect quasi identifiers. And it's not just about your direct identifiers anymore. And then, of course, the scalability points, which I think Greg really brought home, which are the use of ABAC to build policies, in a scalable way. And then, of course, using our logical layer, what he mentioned is those global policies, which are able to reference that logical layer. So you can build a rule once and have it propagate across all your tables. And this is made possible by that sensitive data discovery feature I mentioned earlier, which is Immuta can go in there and through our classifiers, discover that sensitive data. You can, of course, tag it yourself as well, or use other external business glossaries and pull that information in, which is also a capability that we offer. And then just a few closing thoughts here. If you want to learn more, you can go visit the Immuta website /partner/Databricks to learn more about the integration. What I want to really encourage people to do is we have a free trial of Immuta. So if you go to this website, immuta.com/try, you can actually enter your information. We will spin up an Immuta instance for you. You can goof around with it for 14 days for free. We have instructions on how to configure it to your Databricks cluster. You'll be off and running doing everything that we spoke about today. And then please don't forget to leave feedback on this session. We really appreciate it. And thanks for joining us.